Bismillah ar-Rahman ar-Rahim. For today, how to build and simulate simple project in PSCAD software. From the beginning, we create new project. So we name it simple project. Okay. First we go to master main to select component to build single line diagram. We start with source. From source we have here 3-phase power supply, this one, model 2, here model 1. I will use, say we use model 1, Control C for copy, then we go to our project, then Control V for paste, then Control R to rotate. Okay, our supply is star connected air seat, so we have two way. We can go again to master and click back, and we can use here Control C, then go to our project, Control V to paste, then we can wear by wear mode, click here, then click to 90 degree, then click here. By this way we can connect earth point to our star point. The next step, double click in power supply. Here in power supply we have to enter the voltage magnitude line to line RMS value, then we have to enter frequency and short circuit level. So here the short circuit level we enter it by impedance value, so we select source, impedance type inductive. Our impedance data format, we enter impedance value by ohms. Okay, here our base MVA, leave it 100 MVA. Our voltage we use 33 kilovolt, frequency 50 Hz. This ramp time for power supply 0.05 second. This is the data. Then I have I won't use single line diagram, so I select single line view instead of 3-phase view. This is the required data here in configuration. Click here in arrow, I go to positive sequence impedance. Okay, our short circuit level is 1000 MVA, so we can calculate it by 33 square over 1000 MVA. The result is 1 ohm, approximately 1 ohm. Okay, for voltage, our source is fixed voltage 33, frequency 50, phase angle 0. We go back to configuration and I can change for 0 sequence impedance here already equal to positive sequence, but if different I will choose here 0 sequence different from positive sequence, so click it for yes. Then I go to 0 sequence impedance and I can enter 0 sequence impedance maybe 0.5. That is all about power supply. So here I have to rewire it because the zero sequence impedance is different from click from positive sequence impedance. Okay, next step. Our single line diagram contain power supply, circuit breaker, overhead lines, and load. So I go to master. For circuit breaker, I go here for more on breakers and faults. This three-phase breaker single line view. Press Control, click, and also I can click the control logic for circuit breaker. When I use circuit breaker, I have to use control logic for timing, opening and closing circuit breaker. Press Shift M. I can change the arrow from to forward. Okay, the name of this breaker is BRK. I have to use signal. If I don't get this one, I go here for components, then data label or signals, rename this signal for BRK, then wire it to time it breaker logic, then connect breaker to power supply. Save. Okay. For transmission line, it's a little bit different. Right click here in workspace, right click, then go to create. From create, when I want to use transmission line or cables in PSCAD, by this way, create, then T line or cable. I go to T line. Click. The name of this line is T line 1. Finish. Close. If you go here to main, you get T line. Okay, this is our this is our transmission line. So how I can change it to make it straight forward. Okay, this is our transmission line. I have to define configuration for this line. First, right click, go to edit parameters. Frequency is 50 Hz. Length of line 50 kilometer. Number of conductors 3. This for configuration. Here for manual data. Okay, that is all here. Okay, then double click on T line. Here for configuration, go to master, click home, then back. Okay. Go here for more on transmission line. I choose my configuration. My configuration is triangle, so I go to this one. Copy, Control C, go to our project here and Control V. This is our configuration. Okay. I have it. I have to enter the height of bowl and space in between conductors. So double click. Okay. So height of balls is 10 meter, and horizontal spacing between conductor. Horizontal spacing between conductor. This one. The spacing between conductors is 1 meter. This distance is 0.5 meter. 0.5. And vectoral offset of central conductor 0.5. Ground wires 1 meter from C1. Spacing between ground wires, say it 1 meter. Then here for conductor data, we have to enter outer radius of our conductor and DC resistance. This for ground wire. I don't have bundle here. I think this is all about transmission line. Check space height 10 meter. From here to here 0.5, and from here to here is 0.5. Okay. Back. This all about transmission line. For loads, go to master, back. I have to go to passive element. Here, more on passive element. Click. I want to use 3-phase load, active and reactive. Press control, active and reactive, control C, copy, go to project, then control V for pasting. I can also use bus bar, go to components, use bus bar, control R for here, and control C, copy, and then control V here. Just I have to rename this bus 1, and here is bus 2. Alright. Also I want to use measurement. I can use multimeter at sending point and multimeter at receiving point. That is all component. Just go to where, click, then press escape. Click from bus bar to multimeter, press escape. From here to here, escape. Click here and click here, then escape here. And for our load, escape. You can use active, just say 5 megawatt, voltage 33 RMS, voltage line to line. And for reactive power also 5 megawatt, voltage 33. Here I have enter frequency 50 Hz. Connection is start. Air seat. Okay. The last thing for measurement, double click multimeter. I want to measure an instantaneous current. Yes. Measurement in instantaneous voltage. Yes. Active power. Yes. Reactive power. Yes. RMS voltage. Okay. Analog or digital? Digital. Base voltage is 33. Frequency 50. Animated display to display the active and reactive power. Oh yes, click it yes. Okay. Also I have to name signal names, rename signals. For an instantaneous current I use I, instantaneous for sending point, instantaneous voltage V, instantaneous ascending point, active power is B S, reactive power QS, RMS voltage is V at S at sending point. By the same way for multimeter at receiving end, measure phase angle. I don't want to measure phase angle. Frequency 50. For here I instantaneous R and V instantaneous at receiving point, active power BR, reactive power QR, then VR. I can also measure the voltage and current by voltmeter and ammeter. If you want to use ammeter in series, click ammeter, then can also use okay, leave it IA. Also voltmeter for this bus connected to this bus EA, or use this one if you want to measure line to line voltage. Okay. All right. Okay, for display measurement we have to use signal data. For every signal name, let us remember I instatenous, IIS, I capital IIS, and for VIS, and for VR, RMS value, and for active bar PR at sorry, here this one for sending, and also this one for VS sending. Okay. The last one is QS. Then I have to use output channel connected to our signal. By this way I can display the measurement. Then connected, it's good. Wire mode, also I can name output channel by signal names VIS and VS, PS, QS. Alright, for instantaneous, right click here on output channel, then go to graphs meter controls, then go to overlay graphs with signal. So I can this instantaneous current for 3-phase current, line 1, line 2, line 3, or ABC. I have also another way. If I want to extract line 1, line 2, line 3, I have to go to data tab. Here I have to use 3 data tab. This one, this index number 2, and this third one is index number 3. Then also I have to use output channel. Connect it. by this way I can extract, then connect this 3 1 together and use signal with IIS, then connect it here and rename this IA for phase A. This one would be IB for phase B. Okay, this IC. This one IB. And then also go to graph meter and control, then overlay graph with signal. Here only I can extract IA, IB and IC. I have also another way for RMS value for voltage as meter. For here I use control panel, then right click, go to graphs meter and control and add it as meter, then here best. Here RMS value from 0 to 33, set up to 50 kilovolt. Unit is kilovolt. I can display the measurement as meter. Here this instantaneous sine wave. Okay, then for active power, also add as overlay and reactive power. Here for active power by megawatt, max by max set 10 from 0 and grid set 2 to change here. Also for reactive power 10 from 0 to 10, because our load is 5 megawatt. So, if I want to, if the workspace here is limited, I can go to view, then size I can use A3, so I can back to home, go to component, if I copy frame, then here in control paste, it's not by this way. Okay, leave it as overlay graph. So our current unit is kilo ampere. If I want to make it ampere, I have multiply by 1000 as a scale factor. for all of them. 1000 for B, also 1000, and for IS here also make it 1000, and unit is ampere, not kilo ampere. For voltage is kilovolt. Also for instantaneous is kilovolt. For active power unit is megawatt, and for reactive power unit is megavar. Then the last one is V instantaneous. V instantaneous also has overlay graph. Oh, sorry. VS VA instantaneous for instantaneous voltage as overlay graph. Alright. Just try to arrange this IA. I can also for is this one IB? Yes, for IB also add as overlay graph. And also for IC arrange it. Okay, let us compile and run to check if we have errors or not. Okay, now is not yet. Okay, now start only. Okay, that's good. Okay, if we look here for amp, I think is our scale is we have to make it bigger. Just say 50 amps plus minus, because here is instantaneous from peak to peak. So resolution 10. I think we have 50 not enough. 100 to minus 100, and grid is 20 or 25. Yes, so same for here. 200 minus 200, 50. Minus 200, and then 50. 200 amp to minus 200, grid 50. Okay, here for IS is 3 phase. If we try to, you can see the 3 phase, but here is for phase A, phase B, and phase C. Also I can change this color. For phase A is red. Okay. And for phase B, yellow, and for phase C is blue. Okay, this for current. Here for kilovolt we have 50 or 60 to minus 60, 10. Here is line to earth. So we get 19.05. That means 33 over square root 3, but here is peak to peak times square root of 2. That means like 25, 26, 26.9 or 27 kilovolt. For here is a 5 megawatt and 5 megawatt for active and reactive power. Okay, what else? For breaker timing, the operation of breaker once and initial instead open, after 1 second close. Also here I have to go to project to runtime to specify runtime is about 2 seconds. Here go back and run. Yes, at 1 second we get but here it look like we have DC component because of line. And if we look here at single line diagram, we have power 4.4 at sending point and 4.3 for megawatt. The difference is losses for Q, here 4.3 and here 4.6. The voltage here is 30 by kilovolt, here 0.99. Here it look like we have base voltage. If we want it by bare unit 99.99. Here, because I'm not using base voltage, we get it by kilovolt. If we put base voltage, we can get by bare unit. And if we change time of breaker at 0.5, close at 0.5 second, okay. The last thing I want to show here, if we have 3 separate phase current like this, IA, IB, IC, so I can show it only in one graph. So let us try. This breaker is always close, more 5 seconds, more than runtime second, 2 seconds. Okay, for these 3 graphs, red, yellow, blue, I can put it only in one graph. How? Just move here IB to this graph, IA graph, so I can show IA and IB, and delete this graph, delete it. Also for phase C, just drag IC to main graph, so I can show IA, IB, IC as instantaneous current here. Alright, the last thing, if you have say power factor here, auto master, and say it is variable capacitance or variable capacitor, control C, copy, then came here and control V. Okay, we need earth, then connect it to main bus bar. This is a variable capacitance. How we can change the value of the capacitance? Branch type is C type. Capacitance, we can put it here. Just say 0.8. That means about 150 kilovar at 33 kilovolt. We can just put it like this. Maybe the voltage here, yeah, a little bit from 30 kilovolt up to 39.9. You see here there is more voltage drop on this line because this line is too long, 50 kilometer. At no load, as Ferranti phenomena, you will get here over voltage, but with loaded you will get, this is a bad aspect of long transmission time or long line. Alright, another way to change this C here, just we put it as real value. We can just type C1 as a variable parameter. C1. Okay, we go to component, then I go to slider. If we have a slider here, yes, here slider. Then from this slider to signal. This signal name, it should be C1. Where the slider. After that, you go to control panel. Just right click, add as control here, add as control, and go here in control panel, just paste. We can say the unit is microfarad, and the maximum value 1 microfarad, minimum value 0, initial value 0.5 or 0. By this way I can change the value of C. So Control S for save, and go to home, run again. Without capacitor, that means if we 0 run, the voltage here, this capacitor bank work as voltage support at receiving point end. Okay, 0 not acceptable, so just say 0.01 or 0.01, run again. Yes, here about 30.89 kilovolts. So I can increase the capacitance, the capacitor bank up to 1 microfarad. Then run again. Yes, we get by 1 microfarad we get 31 kilovolt, and so on. I think this basic for how to draw, build, run, compile, and run simulation by PSCAD, and how to create transmission line, circuit breaker, load, and how to display our measurement by different ways as a meter or graphs. And finally we shown variable capacitor bank. Thank you for watching and supporting.